afternoon, everyone. So this time we'll talk about problems and solutions on parabola and hyperbola. So first we have here problems and solutions on parabola. Number one, which of the following is the equation of the parabola with axis of symmetry parallel to the y-axis, and the parabola passes through the points 0 and 0, with the second one 3 and 0, and the third one is negative 1 and 4. We have here four choices. First one, we have x squared minus 3x minus y equals 0. The second one is we have x squared minus 3x plus y equals 0. And letter C, we have x squared plus 3x minus y equals 0. Lastly, we have here none of the above. So, in determining actually the equation of the parabola, so there are properties that we are going to follow. Obviously, because these given points are 3, so this parabola talks about having a center at h and k. So we have here the solution. So we have here the parabola with vertex at h and k. The first equation, we have y minus k squared is equal to 4p times x minus h. So this parabola actually with horizontal axis of symmetry. Then the second one, we have the quantity of x minus h squared is equal to 4p times y minus k. This parabola with vertical axis of symmetry. So talking about in the problem, we have here parallel to the y-axis. So when we talk about parallel to the y-axis, so it refers to the vertical line. So if it is vertical line, so this problem belongs to the second equation, which is the quantity of x minus h squared is equal to 4p times y minus k. So first, we have here the point or the coordinate 0 and 0. So all we have to do is we have to replace x as 0 and y as also equivalent to 0. So solving for the remaining quantity we have here, from that we have 0 minus h squared is equal to 4p times 0 minus k. Simplifying, we get h squared is equal to negative 4pt. So that is actually the first equation from the first point at 0 and 0. The second one at point 3 and 0. So same equation that we're going to have, because this point having 3 and 0, x actually is equal to 3 and y is equal to 0. So same equation, we have 3 minus h squared is equal to 4p times 0 minus k. And simplifying, we can actually simplify this 3 minus h to the power of 2 using the property of multiplying the 2 binomial 3 minus h. Then when we simplify that one, that is actually equivalent to 9 minus 6h plus h squared is equal to negative 4pk. So in the previous one, we have the value of negative 4pt as equivalent to h squared. So instead of writing negative 4pk, we can replace that one by positive h squared. So we have here 9 minus 6h plus h squared is equal to h squared as the value of negative 4pk. Solving for h, we have here 9 minus 6h plus h squared. We transpose the h squared from the right hand side to the left hand side. So from positive, it will become negative. Then h squared and minus h squared become 0. So the remaining quantities, we have here 9 minus 6h is equal to 0. We can now transpose the other quantity to the other side. Then solving for h, so we have 3 over 2 as its value. Then lastly, at point negative 1 and 4, so x in here is equal to negative 1 and y is equal to 4. So we have this quantity negative 1 minus h squared is equal to 4p times 4 minus k. Then simplifying, we have here 1 plus 2h plus h squared. Same as in 3 minus h, we use the property of binomial. Multiplying these two binomial, negative 1 minus h times negative 1 minus h. So equivalently to 1 plus 2h plus h squared is equal to positive 16p, because we use this derivative property. So we have 4p times 4 that is 16p. Then we have 4p times negative k is negative 4pk. Then in the previous step, we have negative 4pk as equivalent to h squared. So after the term 16p, which is minus 4pk, we can actually replace that one by positive h squared. So we can now have 1 plus 2h plus h squared is equal to 16p plus h squared. Then we know that the value of h is equal to 3 over 2. So instead of writing h, we will have to write its value as 3 over 2. So it will become 1 plus 2 times 3 over 2 plus the quantity of 3 over 2 to the power of 2 is equal to 16p plus, in the right hand side we have h squared, then we have 3 over 2 to the power of 2. Simplifying, we have 4 is equal to 16p because from here 2 times 3 over 2, then 2 it will be cancelled out, so we have 1 plus 3. Then when we transpose 3 over 2 from the right hand side to the left hand side, having the power of 2, it will become negative. So from the left hand side, we have positive 3 over 2, so that would become 0. 4 now is equal to 16p. Then solving for p become, okay, we have 4 is equal to 16p. Then dividing both sides by 16, p now is equal to 1/4. Next, we have here the remaining quantity that we're going to identify is the value of k. Then remember that in the previous steps or slides, we have h squared is equal to negative 4pk. We already have the value of h and the value of p, so all we have to do is replace the value of replace h by 3 over 2 and p by 1/4. So become the quantity of 3 over 2 to the power of 2 is equal to negative 4pk. Then p is equal to 1/4, so we can have k now is equal to 9 over 4. Then dividing both sides by negative, k now is having a value of negative 9 over 4. Then we know that the value of our h is 3 over 2. Then the value of our p is 1/4. Then the value of k is 9 over 4 or negative 9 over 4. So we have here this corresponding equation from the given three coordinates. We have x minus 3 over 2 to the power of 2 is equal to 4 times 1/4 times the quantity of y plus 9 over 4. Simplifying, we have x squared minus 3x plus 9 over 4. And that is equivalent to, because when we multiply 4 times 1/4, the answer will be 1. Then times the quantity y plus 9 over 4. So the quantity that will be, or the resulting quantity will be same, which is y plus 9 over 4. Then from that, we can transpose actually 9 over 4 from the right hand side to the left hand side, or all those quantities from the right hand side. So the sign will be changed from positive become negative. Then we have here x squared minus 3x. So we have from positive y become negative y. Then just copy 9 over 4. Then from the 9 over 4 from the right hand side, we will transpose that one to the other side. So it will become negative 9 over 4 equals 0. Then simplifying, we can now have x squared minus 3x minus y equals 0. Therefore, the answer is letter A. We have x squared minus 3x minus y equals 0. Okay, let us now proceed to the second problem. Which of the following is the equation of the parabola that passes through the point negative 1 and 5 and its vertex is at 1 and 1 with a vertical axis of symmetry? Okay, we have here these following choices. From the first one, we have x squared minus 2x minus y minus 2 equals 0. Letter B, we have x squared plus 2x minus y plus 2 equals 0. And letter C, we have x squared minus 2x minus y plus 2 equals 0. Then lastly, we have none of the above. Okay, so again, this type of parabola having a vertex at h and k. So remember that this parabola passes through the point negative 1 and 5 and its vertex is at 1 and 1. So for us to determine which of these two equations that we're going to have or to use using these given quantities is that we have here given from the last statement of the problem, which is this problem having a vertical axis of symmetry or this parabola. So therefore, looking into the properties of parabola, we have the first one, okay, with horizontal axis of symmetry. In the problem that is being described is vertical, so we will use the second equation because it has a vertical axis of symmetry. So the second equation from the third column, no? In the second row, we have x minus h to the power of 2 is equal to 4p times y minus 2. Okay, solution from the point where the parabola passes through, we have negative 1 and 5, where x is negative 1 and y is positive 5, having a vertex at point 1 and 1 that corresponds to a value of h is equal to 1 and k is equal to 1. Then, using the second equation, okay, we have x minus h to the power of 2 is equal to 4p times y minus k. So instead of writing the value, writing x and writing y, we will have to replace them by its corresponding value, which are negative 1 and positive 5. Then it will become, then we have also here the value of h as equivalent to 1 and also the value of k, which is also 1. Simplifying, negative 1, the quantity of negative 1 minus 1 to the power of 2 equals 4p times 5 minus 4. We can now have in the left hand side, it will become 4 because negative 1 minus 1 is negative 2 to the power of 2 is positive 4. While in the right hand side, we have 5 minus 1 is 4 times 4p is we have 16p. Solving for 4p, p now is equal to 1/4 by dividing both sides by 16. Then, using the equation provided from the second one, we have here x minus 1 and x minus 1 to the power of 2 is equal to 4 times 1/4 as the value of p, which is 1/4 times y minus 1. Okay? Then, simplifying, we have here x squared minus 2x plus 1 equals y minus 1. We can now transpose all the quantities from the right hand side to the left hand side. Then we have here x squared minus 2x minus y plus 1. Then from negative 1 from the right hand side, it will become positive 1. So we have x squared minus 2x minus y plus 2 is equal to 0. So our answer for this problem, the second problem for parabola, is letter C. We have x squared minus 2x minus y plus 2 equals 0. Then we have here problems and solution on ellipse. Okay, this is the first problem for ellipse. So this problem actually for an ellipse having a vertex at point or center at point 0 and 0. So we have which of the following is the equation of an ellipse with foci at positive and negative 4 and 0 and a vertex at 5 and 0. So remember always that if we have these given quantities wherein the quantity from the first, now from the given ordered pair, the first quantity is greater than 0. So it will signify that the major axis is along with the x-axis. So particularly the equation that we're going to have or to use is x squared over a squared plus y squared over b squared is equal to 1. Then, because it has a corresponding vertex at plus minus a and 0. Tapos yan ang equation. Then we have here the following choices. We have y squared plus 25 plus x squared over 9 equals 1. And letter B, we have x squared over 25 plus y squared over 9 equals negative 1. And letter C, we have x squared over 25 plus y squared over 9 equals 1. Lastly, we have none of the above. Okay? So let us figure out which of these two equations from the ellipse given this table of properties of the ellipse with vertex or center at point 0 and 0. So remember always that in the given quantity, the foci having plus minus 4 and 0. So looking into the properties corresponding to each vertices of these two given equations, the first equation having the vertices of plus minus a and 0. The second one is 0 and plus minus a. So obviously the first equation will satisfy this type of problem. That is x squared over a squared plus y squared over b squared equals 1. So in the problem, we could easily figure out that our value of a is equal to 5 and our value of c is equal to 4. Then, using the first equation now, with vertex at plus minus a at 0 and focus at plus minus c at 0. So we have here a is equal to 5, then a squared now is equal to 25 because when we have a squared, it means that we have to multiply 5 times 5, so which is equivalent to 25. And for c is equal to 4, then we have c squared is equal to 16. All we have to do now, because we already have the value of a squared, okay, the quantity that we're going to identify this in the second part is the value of b squared. So that can be obtained using the formula from the equation, okay, where c is equal to square root of a squared minus b squared. And provided that a at this time is greater than b. Then using that one, we have c squared, or c is equal to a square root of a squared minus b squared, or c squared is equal to a squared minus b squared. Then the value of c squared is 16, while the value of a squared is 25. Then we will transpose the other side. This 25 become negative. Simplifying, we get negative 9 is equal to negative b squared. Then dividing both sides by negative, b squared now is equal to 9. So finally, we have the equation x squared. From the original one, in the first equation, we have x squared over a squared. We will replace a squared by the value of a squared, which is 25. So that's why we have x squared over 25. And in the second one, in the second term, referring to the numerator, denominator rather, we have b squared. Then we already have the value of b squared, which is 9. So instead of writing b squared, we will have to write its value, which is 9. So that's why we have the answer x squared over 25 plus y squared over 9 equals 1. So therefore, the answer for the first problem on ellipse, we have letter C. Okay. Another problem on ellipse, we have which of the following is the equation of an ellipse with length of the latus rectum is 8 over 5 and the vertices have coordinates 0 and negative 5 and 0 positive 5. Letter A, x squared over 25 plus y squared over 4 equals 1. Letter B, x squared over 4 plus y squared over 25 equals 1. Letter C, x squared over 25 plus y squared over 9 equals 1. And letter D, none of the above. Okay, so we have here these properties. Okay, we have the table of properties of these two types of equation of an ellipse. Remember that the given coordinates for the vertices, the first number is 0. We have 0 and negative 5 and 0 and 5. So, looking also the properties in the table, the second property, which is 0 and plus minus a, will satisfy to this given problem. So, obviously, the second equation will be applicable to solve this type of problem. Okay? So we have this solution, x squared over b squared plus y squared over a squared equals 1. We use the second equation. With vertex at point 0 plus minus a, so obviously our a at the time, because we have the given coordinates for this vertex, we have a is equal to 5, then a squared now is equal to 25. Remember always also that we have the length of the latus rectum. That is the formula having 2b squared over a is equal to 8 over 5. Then remember that our value of a is equal to 5. So instead of writing a, we can now have 2b squared over 5 as the value of a, which is 5 is equal to 8 over 5. Then simplifying, 2b squared now is equal to 8, or b squared is equal to 4. Dividing both sides by 2, so b squared now is equal to 4. In the second table, we can actually identify where we get 2b squared over a. That is actually corresponds to the length of the latus rectum from the second part, which is 2b squared over a. The second, in the second row in the third column. Uh, Next, we have the value b squared and a squared. So obviously our answer is x squared over 4. 4 is actually our value for b squared. Plus y squared over 25. 25 is the value of our a squared is equal to 1. So therefore, the answer is letter B for the second problem on ellipse. Next, we have here another problem on ellipse. Which of the following is the equation of an ellipse with center at 4 and 3, and the length of the horizontal major axis is 5, and the length of the minor axis is 4. So very easy to identify which of the two type of equation of an ellipse with vertex or with center at h and k, because we have here horizontal major axis is 5. So therefore this type of ellipse, the major axis is along with x axis and the minor axis is along with y. Then remember that the formula for the length of the major axis is 2a, and while for the minor axis is 2b. So 2a is equal to 5 obviously. Okay, so we have this given table. The major axis, horizontal. Look at the directional for the first one. Sa major axis, we have direction is horizontal. So meaning the formula, the length is 2a. So 2a now is equal to 5. Then when the minor axis is 4, then the formula is 2b. So 2b is equal to 4. Okay, solution. We have center at point 4 and 3 with h is equal to 4 and k is equal to 3. Then we can actually use the first type of equation uh, because the major axis, its direction is horizontal. Then 2a now is equal to 5, dividing both sides by a. So we have by 2 rather, a now is equal to 5 over 2. Then therefore, a squared is equal to 25 over 4. By multiplying 5 over 2 times 5 over 2. While in the minor axis, its length, we have 2b is equal to 4, dividing both sides by 2. B now is equal to 2, then b squared is equal to 4. So we already have the value of a squared and b squared. All we have to do is we will have to replace the value of h and the value of a and b in the equation that we used from the first one. So finally, we have the quantity of x minus 4 to the power of 2 over the value of a squared, which is 25 over 4 rather. That is not 2. 25 over 4 na siya. Plus the quantity of y minus 3 over 4 is equal to 1. So our answer will be what? Letter B, x minus 4 to the power of 2 over 25 over 4 plus y minus 3 to the power of 2 over 4. So that is letter B. Next, which of the following is the equation of an ellipse with center at 7 and negative 2? Then we have the vertex at point 2 and negative 2, and the endpoint of the minor axis is at 7 and negative 6. So for us to determine also which of the two types of equation of an ellipse with vertex or center at h and k is that we have to compare the center to the vertex. Remember that in this coordinate 7 and negative 2 and the vertex with the coordinate of 2 and negative 2, their corresponding first number having different values. We have the first is 7 and the second is 2. While the second value referring to y, we have negative 2 and negative 2. So obviously, we can distinguish using the table of values or table of properties of these two types of ellipse. So we have this table. Accordingly, the first number must be different. Okay, so we have h and k. Then referring to the vertex, of course, the first equation is actually applicable to this type of problem because we have center at h and k. Then the vertex for this first type of equation, we have the quantity of h plus minus a and k. Okay, so obviously in the first number from center and vertex are different to each other, no? They differ each other. So we have to use x minus h to the power of 2 over a squared plus the quantity of y minus k to the power of 2 over b squared is equal to 1. Then we have that. Solution, the center having 7 and negative 2 with vertex and 2 and negative 2 with corresponding value of h is 7 and corresponding value of k is negative 2. Then looking back into the vertex, we have h plus a, then corresponding value of the vertex which is 2. So h plus a is equal to 2. And remember that our value of h is 7, so 7 plus a is equal to 2, or a now is equal to negative 5 because we transpose 7 to the other side, so it will become 2 minus 7 is negative 5. Then a squared now is equal to 25. While k plus p, where did we get this one, is actually from the endpoints of the minor axis. So we use k plus b that will correspond to a value of the endpoints of the minor axis corresponds to y. No? To y nga. X and y man yung coordinates. So we have 7 and negative 6. So we will have to use negative 6 because that is the value of y. So k plus b is equal to negative 6. Then our value of k is negative 2. Then simplifying, we get b is equal to negative 4. Then b squared now is equal to positive 16. So we have here the value of b squared as a squared. So obviously we'll have to replace this given equation from the first, no? From the value of h, the value of k, and the value of a squared and b squared. So we have x minus 7 to the power of 2 over 25 plus y plus 2 plus the quantity of y plus 2 rather to the power of 2 over 16 equals 1. So therefore the answer is letter A. Next, we will tackle now about problems and solution on hyperbola. Okay? The first problem we have, which of the following is like the standard form of the equation of the hyperbola with vertex at point 8 and 0 and negative 8 and 0. And one of the focus is at 10 and 0. The following choices we have here given. Okay, we will directly proceed to the table of values and a table of these properties of hyperbola. So because this given point having one of the value for each coordinate is 0, so obviously that is having a center at point 0 and 0. Okay, so we have the vertex at point 8 and 0 and negative 8 and 0. So in here, the table of properties for this para hyperbola, the first one we have plus minus a and 0. So nauna yung value greater than 0. Okay, before 0. So that will satisfy to this given problem. So the first equation will solve this type of problem, which is x squared over a squared minus y squared over b squared equals 1. Okay, so we have the center is at point 0 and 0 with vertex 8 and 0 and negative 8 and 0. Then a is equal to 8 because we have the formula for the vertices plus minus a and 0. So a is equal to 8, then a squared is equal to 64. Since the focus is at point 10 and 0, then the focus or the foci has a formula of plus minus c and z. So obviously c is equal to 10, okay? Then c squared is equal to 100. Then we will also use the formula for c for us to identify the value of b squared, which is c is equal to square root of a squared plus b squared. Then, or simplifying, taking squared both sides, c squared is equal to a squared plus b squared. Then we will replace the value of c squared as 100 and the value of a squared, which is 64. Then simplifying, we transpose 64 to the left hand side, become negative 1 or negative 64. So 100 minus 64 is 36. That is the value of our b squared. So obviously our answer, we have x squared over the value of a squared, which is 64, minus y squared over 36 as its value for b squared is equal to 1. So therefore the answer is letter A, x squared over 64 minus y squared over 36 equals 1. The second type of problem for the hyperbola. Which of the following is a standard form of the equation of the hyperbola with center at point 4 and 3 and the length of the horizontal transverse axis is 5 and the length of the conjugate axis is 4. So in this type of hyperbola, the major axis or the horizontal transverse axis is along with x-axis. So we have these four choices. We will now proceed to the table of properties for these two types of parabola, hyperbola. Okay. So with center 4 and 3, so in here, the length of the horizontal transverse axis. Okay, horizontal. Transverse axis, tapos horizontal at pangitaon. So we have this one corresponding to this property of the first equation, which is the quantity of x minus h to the power of 2 over a squared minus the quantity of y minus k to the power of 2 over b squared equals 1. Okay, with h is equal to 4 and k is equal to 3. Then we have its formula actually for the transverse length niya is 2a while the conjugate is 2b. So we have here, we have this one. Okay. 2a is equal to 5 because as the formula for the transverse and its length, then is equal to 5 over 2 by dividing both sides by 2. A squared now is 25 over 4. Then 2b now is equal to 4 as the formula for the conjugate axis referring to its length. Then b now is equal to 2 because we divide both sides by 2. B squared now is equal to 4. So finally, we have the answer, the quantity of x minus 4 to the power of 2 over 25 over 2 minus the quantity of y minus 3 to the power of 2 over 4 equals 1. Therefore, the answer for this problem, we have letter A. Okay. Next type of problem. Which of the following is the standard form of the equation of the hyperbola with focus at 4 and 6 and the vertices are at 4 and 3 minus square root of 5 and 4 and 3 plus square root of 5. So we have these four choices. Okay. We have this formula or properties of hyperbola. As what we observe that in the center, in the focus, we have 4 and 6. Okay. With focus at 4 and 6, then we have the vertices are at 4 and 3 minus square root of 5 and 4 plus 3 times 3 plus square root of 5. Then, we can now have the solution. The vertices having 4, 3 minus square root of 5, or then we have 4 and 3 plus square root of 5. Remember that the vertices has the formula of h plus minus a and k. Okay, then we have also here the focus at point h plus c and k. So at this type of problem, because the vertices are given, all we have to do is determine the center by adding the x value for the two values for vertices or two coordinates for the vertices. So we have 4 plus 4 over 2 is 4, while the value of k is equal to 3 minus square root of 5 plus 3 plus square root of 5. Dividing by 2, it has a value of 3. Then we have the center at point 4 and 3 and focus at point 4 and 3. So as what we observe, the first value would be the same. Looking back into the center or property of this parabola, the center is at point h and k. Then the focus has h plus minus c and k. Is not actually compatible to this type of problem because in the first x value for each type of coordinate for center and focus are the same, but in the first type of property of this equation, ilang first value are not actually the same. So obviously, that is in the second equation, which is the quantity of y minus k to the power of 2 over a squared minus x minus h to the power of 2 over b squared equals 1. This type of equation is actually compatible to this type of problem because the first in the center corresponding to the value of x or h and the focus of this given hyperbola in the second equation looking into the foci having h and k plus minus c. So obviously h and h are actually equal at this time. And therefore, we'll have to use that equation. y minus k to the power of 2 over a squared minus the quantity of x minus h to the power of 2 over b squared equals 1. Okay? So from that, we can have k plus c. No? K plus c, that is referring to the focus. K plus c, we have equivalent to, we have here equivalent to 6 because the value of our, we have here the focus at point 4 and 6, so we have 6 referring to the value of y. Then the value of k is 3, so we have 3 plus c is equal to 6. Simplifying, c now is equal to 3 or c squared is equal to 9. Then from the vertex, we have k plus a as its formula for the vertices, k plus minus a. So equivalent to 3 plus square root of 5. Then the value of k is equal to 3, so 3 plus a is equal to 3 plus square root of 5. Then it will become, this 3 become negative 3, so the remaining quantity from the right hand side will be square root of 5. Then a squared now is equal to positive 5. At this time, because we already have the value of c squared and a squared, we can now have the value of b squared by using the formula c is equal to square root of a squared plus b squared. Then, replacing value of c squared as equivalent to 9 and a squared is equal to the value of 5. So we can now have the value of b squared is equal to 4. Okay? Then from that, we have y minus 3 to the power of 2 over 5 minus the quantity of x minus 4 to the power of 2 over 4 equals 1. So obviously the answer is letter letter B in this problem. Okay, so we have this problem. This one is not actually belong to parabola, ellipse, and hyperbola. This one is on problems on nonlinear equations. Okay, so try to answer this nonlinear equation. Find the solutions of the equation x squared plus y squared minus 10x minus 10y plus 40 equals 0. When the second one, we have xy minus 5x minus 5y plus 22 equals 0. Okay, so I hope that those examples will help you actually in solving your problems pertaining on parabola, hyperbola, and ellipse.